Hey biology, hope you're doing well when you watch this video. This is my attempt to make a YouTube video. Full disclaimer, not a YouTuber, so it's not going to be exciting or full of whatever cool things YouTubers do. I actually don't even think I can name a YouTuber. Maybe, isn't there like some Mr. Beast guy or something? I don't know. Anyways, it's all good. Theory of evolution. That's what I want to talk to you about today. And we're watching this video just to make sure we don't fall behind. I'm so sorry that I missed. My girls have been sick again, so appreciate prayers, but nonetheless, let's get started. So we talked, last time we had class, we watched that video about how Darwin and Wallace made their theory. And so the first thing that I really want to talk to you about is, what is a worldview? We all have worldviews. A worldview is a way of looking at and explaining life in the world. So like, how do we get here? Why are we here? Where are we going? Who's in charge? If you've ever watched The Croods, the first movie, the daughter Eve, it asks a great question at the start of it. She's like, why are we doing this? You know, and so worldview helps you understand that. Why do you keep pressing on in pain? Why do we keep living? What's the purpose of life? And so we, of course, at Northside Christian teach a biblical worldview. Now, evolution dives into some naturalistic worldviews, and you'll hopefully be able to determine the differences and be able to spot the differences between evolution and creation as we talk in class. But let's just get started as far as evolution goes. So, for example, let me just give you a little case study here. The Spanish flu pandemic is one of the deadliest in history. We're used to pandemics, right? COVID, we've lived through it. But Spanish flu was one of the deadliest in history. About 1/3 of the planet's population was infected and killed an estimated 20 to 50 million victims, including roughly 675,000 Americans. And so, of course, COVID tragically has taken more than that. Of course, you know, there's different viewpoints on those numbers, but that's not the point of the conversation. The point of the conversation is the flu that we experienced this year. Was it the Spanish flu? And of course not. Like the flu that we experienced this year was very different than the Spanish flu. And so what happened? Well, the virus mutated and changed. And so evolution is you know, scientifically speaking, the change in genetic compositions of organisms. COVID-19. You know, it changed. You know, you remember the different variants like Delta, Omicron. So when genetic things mutate and change, that is considered evolution, okay? And so the Bible talks about God created according to his kind. Remember the video that Darwin erroneously thought that God created according to species, special creation. God created every single species for every single habitat, but that's not what Genesis says. Genesis says that God created according to its kind. And so we believe that God created all the original DNA, and within that DNA, there's the genetic potential to develop multiple different organisms, okay? In the beginning, God created. It's a very great truth and a very humbling truth and a wonderful truth that God created you, and God wants you to exist. So let's dive into some of the specific knowledge that you need for, biologically speaking, about the theory of evolution by natural selection, Darwin's theory. Here's some essential questions. What evidence convinced Darwin that species could change? 4 principles of natural selection. We'll talk more about natural selection in class, of course. And what did Darwin do and what did he kind of see? So evolution. So here's some blanks here for your notes. Hopefully you got those in class, but if not, they're on topics. But here is some notes here. And so we have, let me see if I can draw on this. Genetic composition, right? Genes, DNA. I'm writing with a mouse, so don't judge me. I don't have one of those cool pads that YouTubers have. But DNA, changing in DNA population. So evolutionary change is observed in laboratory experiments. I mean, we see organisms changing. We see bacteria evolving. We see different possibly species of finches and pocket mice, you know, and various things that we'll watch about, like changing their colors, changing how they look, changing their beaks. And that is evolution. So why is it important to understand evolution? Why is it important to understand that life changes? Well, it's important to understand that life changes because it helps us understand and treat diseases. How do we treat antibiotic resistance? How do we treat all these diseases that's come about? What about crops? What if you spray a crop with a pesticide and the pest that's invading the crop no longer dies? Well, that's evolution. It's become adapted. Understanding the diversification of life is more of a secular topic, you know, understanding like where we all came from and how all life is related. Although there is some great truths as far as like God did create all things. The entire Bible teaches that. And so it's helpful to understand that. So theory, I've heard some people say like evolution is just a theory. Well, evolution is not just one single hypothesis. Like it's backed by a lot of different observations and experiments and understandings. Okay, so Before Darwin, biologists had suggested that species had changed over time, but no one had proposed a convincing mechanism for evolution. So here comes Darwin, awesome lamb chops, and he spent 5 years on a ship. Obviously not directly on a ship. He stopped for multiple months at various excursions, but his most famous place was the Galapagos Islands. Yeah, remember the video that we watched about, like, he didn't like it, man. He thought, like, if hell had a garden, this be it. But nonetheless, he saw multiple different species there. Species kind of related to the mainland, but different in many ways. And the different tortoises and the finches and all of this, he started formulating his thought about how life could change over time. He was a naturalist, so which meant he collected and studied biological and geological specimens. He loved nature. And nature, I love nature, and hope you do too. Nature definitely speaks of God's glory. So Darwin began, that's kind of what it looked like, 5 years. Crazy to think about that. Here's just another map of that. So the Galapagos Islands, which are right here, of course, off Ecuador, I believe. He noticed that the different islands all seem to have their own slightly different varieties. That's important to see, varieties of animals. And so almost every specimen Darwin collected on Galapagos was new. And so the island and mainland species should not have been so similar unless mainland species had changed since arriving on the islands. Okay, and this is a worldview, right? Trying to understand how life exists, what's the differences, where do they come from? And so Charles Darwin was interested in this history, and his observations showed that to him there were patterns to the diversity of life. And that specifically, which is a huge learning objective in this lesson, organisms are adapted to the environment that they live in. Okay? It's not like evolution produces a perfect species, but it's all about the environment. Okay? And so species, he saw three things. Species vary globally, locally, and over time. And so globally, you can see the different species right here, ostrich, emu, etc., rhea. And so these birds are related, but they're very similar and they live in similar habitats. And so ecologically similar animal species inhabited separated but similar habitats around the world. Darwin also noticed the different tortoises, Hood Island versus Isabella Island. And so Pinta Island had, an intermediate shell. Isabella Island had this huge shell because the vegetation was low to the ground. Well, where do you think the vegetation was was like at Hood Island? It was taller, it was higher off the ground. And so this organism could not survive as well on Hood compared to this organism because you had to reach for the food. However, if this tortoise, the Hood Island saddleback shell, were transported to Isabella, it would have a lower fitness. And so I want you to write that maybe here. It's all about, well, let me actually see if I can type fitness. Oh, no, maybe not. Oh, no, that's not working. Let's exit out of that. Well, that's weird. I don't know how I did that. But anyways, well, let me just try again. Fitness. Sweet. Hey, I'm learning. Okay, so it's all about fitness and all about this organism has a high fitness on Hood because it has a longer neck, more space in the shell to reach for high food. But this organism has a higher fitness level on Isabella because of its protected layer. Food's not an issue, so it needs to be protected. Okay? And so with that being said, species vary over time. He saw the Glyptodon. We saw that in the video, this huge, massive fossil that was kind of related to the armadillo looked similar. And so the fossil record, again, we'll talk more about that homework in a second. But species, here's a couple things that he realized. Species are not immutable, which means they do change. They change over time. That's important. Divergent species that share a common ancestor. We'll talk more about that, the tree of life. Again, according to kinds, we believe common ancestors within kinds, but biblically speaking, it's hard to read that unless you think Genesis is an analogy. But have diverged from one another gradually through time, a concept Darwin termed descent with modification. We're descending with modification, okay? And so the other thing that I want to share, and it's not on the screen, I'm going to fix that, is change in species over time can be explained by natural selection. And here's the definition of natural selection, okay? Very important that you write this down and understand it, memorize it. The differential survival. So some things, based on variation and in their traits. Well, where does the variation come from? the variation comes from, write this down, mutations. Oh, S, mutations in genes. And so random mutations that happen within genes create variation, and based on that variation, you have differential survival rates. Some organisms are better suited to survive and therefore reproduce and pass on those successful genes. And so those are mutations, okay? And so that's what drives the variation. And so several sources indicate that belief in a fixed species was prevalent at the time. And yet, and so continuing onward, we'll talk more about the assignments. We'll talk about all of this. This isn't actual factual stuff, so we'll talk about that. And so here's some background information that you need to know about Darwin. You need to know about different views about the world, these ideas that shaped Darwin's thinking, okay? And so what was, Hutton's view and Lyell's views, Lamarck's, Malthus's view, this would be an S, what is artificial selection? How did Darwin apply this process? And so when you see the Grand Canyon, it's definitely on the bucket list for me. Definitely want to see it one day. Heard it's magnificent. If you've seen it, you are blessed and should be grateful to whoever allowed you to see it. But a lot of people see millions of years. Some Christians see millions of years, and some Christians see thousands of years. At the time, most people thought the world was thousands of years old during Darwin's time. And so, but Hutton and Lyell kind of challenged that view. Hutton and Lyell are considered the fathers of uniformitarianism geology, which basically means that everything that's happened in the past happens at the same rate it does today. Continents move at the same pace, water flows at the same rate, etc., so on and so forth. And so, according to uniformitarianism, the Earth has been around for billions of years, okay? Not thousands that people were discussing at the time. And again, some Christians today believe in thousands, some believe in millions and billions, and those are fun conversations to have and dive into the evidence and support and the arguments for each one. But the biggest thing, the most crucial thing about Christianity, the top tier importance, is believing that Jesus Christ is God's son. So let's move forward. So Darwin asked himself, what if Earth can change over time? And all these people, what about life? And so fossils helped Darwin see that life did change through time. James Hutton and Lyell helped him understand that Earth is possibly millions of years old, naturalism. But Jean-Baptiste de Lamarck, that's an amazing, awesome name, living things have changed over time. So Lamarck actually thought about this, that living things do change over time. And so they respond to their environments, and through either, here's where Lamarck kind of differed a little bit from Darwin, though. Lamarck argued from either use or disuse, organisms acquired or lost certain traits, and then these traits could be passed on to next generations through use and disuse. So let me ask you a question. Let's say this gentleman has a child at his current state right here, and then he, takes some steroids, I don't know, gets in shape, and he has a child then. Is his child when he has now, like when he's, in shape, strong, bodybuilder, is that child more likely to be strong? More likely to be a bodybuilder? More likely to come out with a six-pack, and stuff? And the answer, of course, is, no, that's silly, right? But that's what Lamarck believed. And it's not like it was a bad thought. He was just trying to understand. So how did giraffes' necks get so long? They literally stretch. And the ones that stretch the most passed on those traits. But Wallace and Darwin was like, no, natural selection is just about variation. Some giraffes have longer necks than others, and because they have longer necks than others, the ones with longer necks normally survive more because they get more food and pass those long neck genes on to the next environment. So Lamarck is known as Lamarckism, inheritance of acquired characteristics. That's known as Lamarckism. So it would be a hypothesis. It's not backed by a lot of evidence. Here's a little comic. Stretch. Think about the children. Think about the children. Probably not as funny to you as it is to me, but nonetheless. All right, Thomas Malthus, where I talked about him in ecology. He literally started thinking about what keeps human populations in check. And he was like, man, no, death, war, famine, disease. And so, of course, from the movie, you remember Wallace was thinking about this, and Wallace was like, man, death is a play, right? We have enormous amounts of death to contribute to evolution because only the survival of the fittest, the ones that don't die, pass those genes on, okay? And so Darwin hypothesized that new species could appear gradually through small changes. And Darwin inferred that humans could change via artificial selection, which we'll talk about right now. That's directed breeding to produce offspring with desired traits. We've been doing that since the dawn of agriculture and humanity, basically. Then perhaps the same process could work in nature. And so artificial selection, nature provides variations, right? Nature provides the differences, but humans are selecting. Humans are the selecting agent. And Darwin actually understood this because he bred pigeons. And so he literally was helped in his own studies and developing his theory by his personal work with breeding pigeons. Now let me show you a picture here. So you can see these are all pigeons. All these pigeons are literally related to the rock pigeon by artificial selection. The fancy pigeons shown here, just by selecting certain traits and keep breeding for that selective trait, they all came from this rock pigeon. Look at this. You wouldn't think these birds are related to this rock pigeon, but they are. If you like corn, you have this process to thank, artificial selection. Teosinte, it looked like this. Through thousands of years of artificial selection, modern corns developed. And finally, look at this. All these vegetables. Well, hey everyone, sorry, I had to take a little pause right there to get Josiah, so I'm holding my little son. But here is the last picture of the lecture. So this actually shows artificial selection as well. So what you have here is you have the wild mustard plant. And through artificial selection, selecting certain traits like flowers and stems, or terminal buds, or lateral buds, we have developed all of these vegetables, humankind. Kohlrabi, kale, I've actually never had kohlrabi. Kale, Brussels sprouts, love roasted Brussels sprouts. Cabbage, you're thinking about like St. Patty's Day there. Cauliflower, you ever had cauliflower pizza? Broccoli, of course, everybody's well familiar with broccoli. And so that is kind of the lecture, the first little part of evolution. Thank you so much for watching this. You can go through and answer these last couple of questions here, what you think the answers are. And then here's one more. And then here's one more. And so let me just end this lecture with the good news. You ready? All the way back up to the beginning. In the beginning, God created. And so in the beginning, God already knew that you would exist. And he doesn't make mistakes. And he knew that you would mess up. And he knew that you would need a savior. And so that's why he sent Jesus. So you are no mistake. You're created for a purpose according to evolution, right? All random chance, no purpose. But God has a purpose for your life. So thank you so much for watching. I hope this video was helpful in understanding the first part of our little introduction into the realm of natural selection. God bless.